Now, mostly they will give us questions, and from the question, we should be able to draw, they will ask us to draw the graph of motion. So this session, that's what we are going to look at. After we understand for velocity time graph what the slope and the area under the graph mean, right? We are going to first, the very first process is to be able to draw the equation of motion, the graph of motion when we are given a particular problem. But we need to take note of these things again. Whenever we are talking, mostly in most of this session, we are going to be talking about velocity time graph. So the focus, I want you to understand the focus will be on velocity against time graphs. This is the velocity time graph that we'll be doing mostly. So for this velocity time graph, I want to take note of this. Whenever they say a body accelerates, right? That one, it means that there will be a positive slope up. Let's keep this in mind. Whenever they say the body accelerates, there's going to be a particular, it will be a slope. The slope will come because we said that the slope represents acceleration. So when they are reading a question, they say from here, from this spot, the body accelerates to another velocity. Then there's going to be a particular slope. We are going to introduce a slope at that point. When they say the body decelerates, I don't know what I'm writing it, or choose double C or decelerate, then there will be another slope, but going down, there will be a downward slope. When they said a body starts from rest or comes to rest, starts or comes to rest, so you need to make sure that if it starts from rest, you need to start from the origin. So if it starts from rest, right, this one, you're going to start the graph from the origin. If you say comes to rest, it means that wherever you are, bring it to the x-axis, or bring it to the t-axis until it touches the t-axis. That's what we mean. Don't worry. Let's look at some problems quickly. We start from the very simplest one and see. But keep these things in mind. Let's look at the first question. A car starts from rest and reaches a velocity of 20 meters per second in 5 seconds. So a car starts from rest, right? So as a car was starting from rest. So when a car is starting from rest, right? So it means that the velocity at the starting point, when they say a body starts from rest, means that at the starting, the car was resting, starts from the rest stage. At the rest stage, there is no velocity. So the initial velocity, let's say VI is equal to 0 meters per second, whatever the unit is. If it's kilometers per hour. So the car starts from rest and reaches a velocity of 20 meters per second. So there is a change in velocity. Whenever there is change in velocity, we are getting an acceleration. So there will be a positive slope. So the graph will look like this. Right? Then we have something like this. Right? So I have my time here and my velocity here. So I said with the focus is on velocity time graph. So a car starts from rest. So from rest, meaning I'm going to start from the origin, from rest, and reaches a velocity of 20 meters per second in 5 seconds. So here is 0, but the time is 5 seconds. So we are going 1, 2, 3, 4, and 5 seconds. So yeah, this will be in seconds, right? So from 0, we are reaching which velocity? 20 meters per second. So 20 meters per second, let's say it's somewhere here on the V. So let's say 20 meters per second. We know that this is going to be 0. But we are going to reach that in 5 seconds. So in 5 seconds, we are going to draw. In 5 seconds, we are at this point. In 5 seconds, we are at this velocity in 5 seconds. So we draw a slope from the origin to this in 5 seconds. And the time is 5 seconds. As simple as that. So this is the very first one. Let's look at another one. A vehicle traveling at 30 meters per second comes to a stop in 6 seconds. So here it comes to a stop, meaning that wherever we are going to come down to touch the horizontal axis. So let me put this one here, then draw another line for you. Yes, So I have V and I have T again. But a vehicle traveling at 30 meters per second. This one is not starting from rest, but it is starting from a velocity. It says traveling at 30 meters per second, which is the very first question. So we are having 30 here, right? That's my light going off. And then it comes to a stop in 6 seconds. When we start from here, right? Traveling at 30 meters per second, that's the very first purpose. Then we go from 1, 2, 3, 4, 5, and 6. So we are starting at 30 and we are coming to a stop. So coming to a stop meaning that we are coming to a point where the velocity is now 0. If the velocity is 0, but then it is happening in seconds, in t seconds. So we are meeting here 0, 6, right? From here to here. This is the equation of the motion. This is simply the equation of the motion. My light is back. This is simply the equation of the motion. Let's look at other questions. Yes. So this is another simple question, but it's not simple. So these ones are this one that we did so far are the fundamentals, going up and going down. Let's look at more complex question. So I'm going to draw my horizontal line, right? That's the vertical line, now the horizontal line. Yes. So I'll do T here and I'll do V here. They say a cyclist starts from rest. So the initial velocity VI will be 0 and accelerate to a velocity of 50 meters per second. So let's put 50 meters per second somewhere here, 15 here. But they say the person accelerates from there to 15, right? But in how many seconds? In 3 seconds. So for this particular one, starting from rest, the acceleration happened in 3 seconds. So 2, 3, right? So meaning that at 3 seconds, we are at 15. So there's acceleration. So we are accelerating from rest to here. That's the first thing. When we are not done, then the cyclist continues at this constant velocity for another 4 seconds. Meaning that when we reach here, right, you don't have to start again. But then when you reach here, they say then means that you continue from there. Then the cyclist then continue at this constant velocity. When it is constant, we are not changing the velocity. So we are going to stay at this point. So it's asking for a horizontal line. It's asking us for a horizontal line, right? But that horizontal line is happening how many? For another 4 seconds. It doesn't mean that they're going to 4 seconds, but then when you, the first one happened in 3 seconds, right? We need in this particular constant one, it happens in another 4 seconds. So we mean that we need extra force to add to the 3. So we are going 3, another 4. So that will be 4, 5, 6, 7, 8. So 3, right? So this particular thing is happening in how many seconds? 1, 2, 3, 4. So we are stopping here for the distance. So you're going to stop here. So they say then, so it's because of the then, we are not going to restart, but we are going to start from that point, and we are maintaining a constant velocity. If it is constant velocity, we are expecting a horizontal line that is in line with the constant velocity we are talking about. So we start from rest, we reach the 15. Then they say we should maintain this one constant. So we keep a horizontal line along that constant. If we reach this point and they say there's another acceleration or deceleration, we move appropriately with that. But we are taking it step by step. This is how to draw this particular one. Okay, let's go a step further. Let me draw my graph again, right? This one I will be so this one goes sharp. Let me go further. So I'm having my T here and I'm having my V here. The car starts from rest. So we are still starting from rest and accelerate uniformly to a velocity of 20 meters per second. 20 meters per second in 4 seconds. So that particular acceleration is happening in 4 seconds. So 1, 2, 3, 4. But the thing move from rest to 20. Let's say 20 is somewhere here, right? And then we move in that 4 seconds. So we are expected to do acceleration to a point here. We accelerate to this point. Okay, that's the very first one. So we are done with this particular one. Is then continuous at this velocity. So we continuous at this velocity, meaning at this constant velocity for 6 seconds. before coming to rest uniform. So we are going to do another 6 seconds, right? So it's going to continue 1, 2, 3, 4, 5, 6 seconds. So 6 seconds we are going to stop here. But actually, if you add 6 to this, you are going to get 10. So here we are moving from 4 to 5 to 6 to 7 to 8 to 9 to 10. So this maintaining this constant velocity happen in a millisecond. 6 seconds. So if we add the 6 seconds to this thing, we are going to have a reach as 10. But then this particular constant one that we have from year to year is costing us 6 seconds. But because we wasted 4 seconds over here already. So keep in mind that the total on the graph will be seeing 10 here. But this one happened in 6, this one happened in 4. Right? So you continue from there. You don't restart the graph. Okay, so then what we have now? He then continued at this velocity for 6 seconds before coming to rest uniformly in 5 seconds. Now, after it reaches here for 6 seconds, right? Then they said before coming to rest uniformly in 5 seconds. So you're coming to rest for another 5 seconds, right? Coming to rest meaning that wherever we are, you bring it to the t-axis. That's what I said from the beginning. Wherever we are, you bring it to the t-axis until it meets the t-axis. But they say in 5 seconds. So we need to add move 5 seconds further. So here from 10, we are going to move 11. So from 10, if you add 5, we are going to have what? 15, 11, 12, 13, 14. I think I'm trying to squeeze this, but I have to clean this and extend it. Yeah, so I'm extending this. So T is here, and let's say 15 is here. So 15 is here. But we know that this is going to, wherever it is, we are going to stop, come to rest at this point. So you draw this line to come here, right? So by this particular coming down here cost us 5 seconds. The one that is here cost us 6 seconds. The one that is cost here cost us 4 seconds. So the total time that we have traveled now is now 15 seconds. That's how it works. So you build up on the previous graph. You build up on the previous graph until you get your final destination. But then whenever you have a previous time and there's another time for the next thing to happen, keep building from there. If you have to add, keep building from there, like how we did this from this time, and then you'll be fine getting your final answer. But the things that you have to keep in mind that when you are saying coming to rest, wherever you are, you bring it down to the t-axis like we did here. If you are saying constant velocity, same the velocity, right? You keep it horizontal. If you are acceleration, then you go up. You go up like that. You decelerate, you still go down. This is deceleration. Another way of saying it is that the body decelerates uniformly to rest. So it decelerates uniformly until rest. Or you can say the body comes to rest. Or the body comes to stop. Any way they can say it, they just have it in mind like that. So you see, most of this stuff, we are starting from a point where we are always starting from a starting point where there is starting from a rest. And then the next session, we are going to continue drawing the graph, but this time they are not going to start from rest. They are going to start from a particular velocity, and we'll do the same thing to be able to draw the graph for them. When we're able to draw the graph for them, then we'll continue calculations on them in subsequent sessions in order to make sure that we understand this concept very well concerning linear motion. See you in the next session.